All right. So our topic this morning is on probability, and this is going to be very interesting since it involves a lot of practicals. It involves a lot of experiments. You have to perform an experiment for you to get the result. So we shall be doing a lot of that. And before we begin with the introduction, let's go through uh, the overview of the lesson, and then we can also look at the objectives for this lesson. Okay, so we have this. Lesson overview. In this lesson, we shall be looking at the following. And the first thing there will be the introduction on that's to probability, definition of some technical terms, and then the types of events that we have. We shall also be looking at the sample space for some experiment, the sample space for some experiment, um, definition of probability, the laws of probability, and relative frequency. We shall also consider combination, that's combining both addition and multiplication laws of probability. Then finally, we shall perform experiments uh, relating to selection or without selection. Sorry, replacement or without replacement. If you perform certain experiment, if you select an item to perform an experiment, do you replace it before you perform another experiment, or you do not replace that particular item before you perform another experiment? These are the major things we shall be looking at in this lesson. What do we expect from you? Now, at the end of this lesson, we expect that each and every one of you will be able to determine the sample space of a simple and a compound statement. If you have any simple statement given you, you should be able to determine the sample space. When you have a compound statement, you should also be able to determine the sample space. Calculate the probability of an event. So, knowing the sample space, you should be able to find the probability of an event. We shall go into details of each of these objectives. And then you should also be able to interpret or. When we say or in probability, what does that mean? You should be able to interpret or in probability as addition. You should also be able to interpret and as multiplication in probability. Now, we move to introduction. What is it all about probability? So, we say that in this unit, we shall be introducing ourselves to the concept of probability of an event, including that of several events, that's the compound event, and then show how these probabilities can be computed. Now, the probability of an event, please maybe you can write this. The probability of an event is a measure of the likelihood that the event will occur. So, in probability, we are more concerned about an event occurring. If an experiment's outcome are likely to occur, then the probability of an event E. So we are using the E here to represent event. So if you want to find the probability of that event, that is, you want to find the likelihood of something happening, we say is E, that event is E, and is the number of outcomes in E, that is the number of possible ways of that particular event happening, the number of possible ways of such an activity happening divided by the number of outcomes in the sample space. And that is giving us P. The probability is giving us P here, probability of an event E equal to the number of E, that is the number of times that particular event will occur over the number of S, which is the sample space, the number of possible ways or the number of times that you are going to perform the experiment. If you perform an experiment, let's say 10 times, the number of events for you achieving a particular result is the number of E. And the number of times you've performed that experiment is the sample space. Please complete that. Copy that, then we can continue. So today we shall be looking at the introduction of probability. Introduction to probability. Ajua, can you see it now?
Yes, sir.
Okay. So please, you can write the introduction before we move on.
Okay, sir.
All right. So let's move to the next slide. Definition of some technical terms. We need to know the meaning of each term so that when they mention this the in a statement, you will understand what the information which is required of you. We pick the terms one after the other, and the first one we shall be considering there is experiment. What is an experiment in probability? An experiment is a planned operation. If the science students are performing an experiment in the lab, it is something that has been planned. They prepare for it. So an experiment is a planned operation carried out under controlled conditions. So that experiment must be controlled. They must know what to use to perform that experiment. So you should know, what do I need in order to achieve this result? What chemicals do I need? Which items do I need to perform this experiment? You make sure that you prepare for all those items before you begin your experiment. If the result is not predetermined, predetermined means that you have a foreknowledge of the answer. So in probability, you shouldn't be expecting the result, else you will manipulate the experiment in order to achieve your result. We assume that you don't know the outcome. You don't know what is going to be the final result. then the experiment is said to be a chance experiment. So if it is not predetermined, then it is possible that any result could come. You could achieve any result at all because it is not predetermined. I'm not expecting any answer of head. I'm not expecting to get a particular result. Mine, I want to be fair. Anything that comes, I will accept it. Then we say that the experiment is not predetermined. Now, again, flipping one fair coin twice is an example of an experiment. So if you pick your coin and you toss your coin 2 times, is an example. In the process of tossing, you are performing an experiment. We also have another one here. Throwing of a die is also an example of an experiment. So if you throw a die, I hope you all know a die. I'll introduce you, or I will show you a die very soon. If you throw a die, it's also an experiment, example of an experiment. Okay, get that? Get that definition done, then we move on to another definition. Today, like I said earlier, we shall be taking definitions of certain terms so that we'll be familiar with all this as we move on. Amojunu, are you seeing everything clear? Can you see
Yes, sir.
clearly? Okay. Apedo Root, can you see clearly?
Yes, sir.
All right. Okay, let's move to the next thing. The second one there is trial. What is a trial? It is an activity in an experiment. A trial is an activity in an experiment. Then we also have an outcome. So if you say, I want to try something, you can try it. Okay. We also have outcome. The result of an experiment is called an outcome. So if you perform any exercise, the final result is our outcome. So if you play or you kick a penalty, you know, whatever happens is an outcome. If you score, it is an outcome. If you don't score, it is also an outcome. All right, that is that. Let's go to the next one. Equally likely outcomes. Equally likely outcomes. Equally likely means that each outcome of an experiment occurs with equal probability. This time, meaning that you are giving each of your outcomes equal chances of occurring, which means you are not going to prevent anybody. You give them equal, it should be on a level ground so that everybody who is capable of winning should win. If you lose, you lose. Then we say that it is equally likely outcome. For example, if you toss a fair six-sided die, each face number that is 1, 2, 3, 4, 5, 6 is likely to occur as any other face. So let me show you a coin. Sorry, a die. This is a die. If you toss a die, you will see the die over there. This is a fair die. What it means is that each of the faces there, they all have equal chances of turning up or showing. You see, we have the faces numbered 1 to 6. You see some of the faces. Um, this is 1. Can you see the 1? The dot. If you see 1 dot, it means it is 1. If you see 2 dots, it means it is 2. Can you see the 3 here? Amujuno, can you see the 3?
Yes, sir.
Good. Uh, okay, Kaka Beauty, your hand is up. Let's take that before we continue.
Sir,
Yeah.
please, I can't see what you are talking about.
Oh, okay. You cannot see the die, right? You can't see the die.
Yes, please.
I'm sure it's the network.
Yes, I can see it.
Yeah, it's the network. It will show. Okay,
Okay, sir.
it will come. Good. So this is a die. Now the die we have there, you see, some faces will show 4 dots. That means that 4. That's why if you somebody turn a ludo die, you roll the die, somebody will say 6 miludu, 4 miludu, meaning you are expecting 6 dots, or you are expecting 4 dots, or you are expecting 3 dots. Any of them, they all have equal chance of showing. This is a die, so we have them in different forms. So equally likely outcomes. If you toss a fair coin, a head and a tail are equally likely to occur. So if you pick a coin, your coin, we assume a coin is not having a face and a tail, but we assume that any side of a coin is the head. Another side is also the tail. That is why I can't show you a coin. If I should show you a coin right now and tell you this is a head, you all you you keep that as that is always the head. But any side of your coin, any coin at all, it could be 50 pesos, 20 pesos. One side is the head, the other side we assume is the tail. Good. If you randomly guess the answer to a true or false question on an exam, you are equally likely to select a correct answer or an incorrect answer. So, like when they give us in an examination, when you are giving true or false type of questions, and some people, because you don't know the answer, or if you've calculated, you've solved the question, you couldn't get the answer, then you will be looking through the answers. Which one should I take? Which one should I take? You are doing probability. So you are likely to get the correct answer or incorrect answer. Some people will do that and they will end up getting some scores, correct scores. And some will also do it and they will end up getting wrong scores. So if you give them equal chance, give them all equal chance to happen, then that is equally likely outcome. Akiti Pearl, have you finished copying?
Yes, sir.
Amanyo Jessica, have you finished
Yes,
copying?
sir.
Yes, sir.
Benoni, have you finished?
Yes, sir.
All right. So we move to the next slide. Beauty, can you see the die now?
Yes, I can see it.
All right.
Thank
Agbodo,
you.
you're welcome. Your hand is up.
Sir, please, I can hear.
Please, can you come again? Come again, Bright. Okay, let's continue. Bright cannot hear me. Random sampling. What is random sampling? Random sampling is a part of the sampling technique in which each sample has an equal probability of being chosen.
Sir, please, I can't hear.
Okay, all right. I hear. I'll try to check my volume. Random sampling is a part of the sampling technique in which each sample has an equal probability of being chosen. So you are not being biased. For example, if you put uh, oranges into a basket and you want to choose one, pick one from the basket, you don't want to pick the good ones or the bad ones. You don't want to see what you are picking. You just put your head aside and place your hand into the basket. You don't see the one, you just mix them up, then randomly you select one. So if you are picking one without taking notice of what you are picking, you are selecting randomly. A sample chosen randomly is meant to be an unbiased representation of the total population. So if you are picking something randomly, it means that it is unbiased. It means you are fair, you are sincere, you are not cheating. If for some reasons the sample does not represent the population, the variation is called a sampling error. There could be a mistake anyway when you are doing you are selecting from a group. You are likely to make some mistakes, and we call that mistake sampling error. Yeah, finish this. There's also another technical term we need to know. You will come across this in the course of the lesson. Sample space. Please pay attention to these definitions. Very important. The sample space of an experiment is a set of all possible outcomes. So in an experiment, your expectations, all the expectations gives you the sample space. Three ways to represent a sample space are to list the possible outcomes, to create a tree diagram, or to create a Venn diagram. We shall be making good use of all these three items I've mentioned. The upper case letter S is used to denote the sample space. So anytime you see S, capital S, we are referring to the sample space, which is the same as the universal set. The sample space here is the same as the universal set. That is all the items under discussion. All the possible results will give us the sample space. Next slide. So for example, if you flip a fair coin, so like I said, if you have a coin and you flip the coin, that is, you throw the coin, your sample space, that is S equal to H T. The H there represents the head, and the T also represents the tail, because I said earlier on that one of the faces is assumed to be the head, and the other face, which is the second face, is also assumed to be the tail. Another example, what are the possible outcomes for the throw of a dice? So, like I introduced you to a die. If you throw a die, what are the possible outcomes? The experiment is a single trial if you throw a die once. So the sample space is equal to 1, 2, 3, 4, 5, 6. You know, a die has 6 faces.
Sir, please, I can't hear you.
Raise your hand, please. If you speak like that, I wouldn't know who is speaking. Raise your hand so that I will know who is having a problem. Sabita, do you have any problem?
Sir, please, the person was saying that he can't hear you.
Who is that?
Sir, please, I don't know.
Yes, I want to see the person. Then we see how we can help that person. Thank you anyway.
So it's Joe Bright.
Joe Bright, do you know how to raise your hand? Joe Bright. Okay, I'm sure the network will be corrected. Okay, Joe Bright, I'm sure it will be corrected. You'll get it. Okay, but try to copy what we have there. I'm sure there is a slight challenge with the network this morning, so you cope with us to do this. Now, so like I was saying, a die has 6 faces, and each of the faces is capable to show up. It is possible that if you throw your die, 1 will show, 2 will show, 3 will show, 4 will show, 5 and 6 will show. 2 will not show. 1 and 2 cannot show at the same time if you are throwing the die once. 1 and 2 cannot show. Only one of the faces will turn up. Likewise, you cannot have 2 and 6 at the same time. You can only have one of the faces showing. Good. Amadi Prosperity, can you hear me?
Yes, sir.
All right. Did you get the explanations I've given to the sample space? All right. Let's move on. Event. This is another important definition we need to look at because we shall be dealing with events from the beginning to the end of probability. Event. What is an event? A collection of one or more possible outcomes of an experiment is called an event. So if I want to write the possible outcomes in an experiment, the possible result gives me the event. Uppercase letters like A and B represent event. Yeah, we can use that to represent our event. And again, for example, if the experiment is to flip one fair coin and A might be getting at most one head, the probability of an event is written as probability of A. So this expression here means probability of an event A. Probability of an event A. So if the event is B, then in place of the A there, you put what? B. If the event is D, then in place of the A, you put D. So this is how to write probability of an event A. Is that clear to everybody? Donk or Bright, is that clear to you?
Yes, sir.
Good.
Yes, sir.
All right. So please write that. That is event. Please make sure you pay critical attention to these definitions. Okay. Let's go to the next slide. Okay, the same. Some of the events in throwing a dice are, so if you throw a die, you can get 1. If there are 2, let's say 2 dice, you can also get 1, 2. 1, 2 then means that one of the dice will turn 1. The other one will also turn 1, 2. 2, 5 means that one of the dice will show 2. The other one will show 5 in that order. They are obtained from the sample space S equal to 1, 2, 3 up to 6. So you see the sample space, if you want to write a sample space, we write the set of possible outcomes 1, 2, 3, 4, 5, 6, because a die has 6 faces. Please, in the whole of our conversation in this lesson is going to be a coin, a die, a coin, a die, and some color of some items. All right. Let's go to the next slide. A probability event. And this can be defined as a set of outcomes of an experiment. In other words, an event in probability is the subset of the respective sample space. So yes, if you want to find the probability of an event, the chance or the likelihood of something happening is going to be the number of times that particular event happened over the total event under consideration, the set of possible outcomes under consideration. That's probability event. Types of events. Impossible and sure event. Impossible means something is not likely to happen. It cannot happen. We say this one is impossible. Impossible event. Let's look at what is there. If the probability of occurrence of an event is 0, such an event is called an impossible event. So if the chance of something happening is 0, meaning it cannot happen, we say it is an impossible event. And if the probability of occurrence of an event is 1, it is called a sure event. This is a possible event, meaning the probability is 1. In other words, the empty set is an impossible event, and the sample space S is a sure event. So if you toss a die, once, this is a sure event. The sample space cannot be empty because you are definitely going to get a result if you toss a die. So this is a sure event. You cannot get empty. You will definitely get something. Either you get 1, 2, 3, 4, 5, or 6. So it's a sure event. Agbemo William, are you following what we are doing?
Yes, sir.
Okay. Have you finished copying this?
Yes.
Okay. Atrin, Chaslina, have you finished copying this? Dansu Peace, have you finished copying this?
Yes, sir.
Okay. Simple events. Any event consisting of a single point of the sample space is known as a simple event. in probability. For example, if I have this S equal to, now you should know that the S there represent the sample space. S equal to 56, 78, 96, 54, 89, and E equal to 78, then E is a simple event, because you will see simple event because it is having only one number. This is a simple event. The S there gives you the sample space. This is a simple event. Compound events, it is a combination of two or more simple events. So if you have two or more simple events, you are combining them, we say that is a compound statement. So in probability, the symbols, this is the union symbol. So if you see the union symbol, this symbol, and the intersection symbol in set represent or and end. So the union there represent or, and intersection represent end, respectively. The union represent or, and the intersection symbol there represent end, respectively. Also, or means addition, whilst end means multiplication. So in probability, anytime you see or, we are referring to addition. If you see end, we are referring to multiplication. So or and then your end, they means addition and multiplication, respectively. Let's go to the next thing. Hence, for any two events, that's when you have two events. Please, you write that. Hence, for any two given sets A and B, if you are given two sets A and B, let's see what happened. A union B, and we know that the union there is the same as or. The union you see in the expression there is the same as or. So A union B means either event A or B occur, or both occur. That is, at least one must occur. So A union B means at least one must occur. And in our diagrams, A union B, we know that it is giving us number of A plus the number of B minus the number of A intersection B. So A union B is the same as A or B. And this is the same as, that is, at least one of the event A and B must occur. For example, let A equal to the set 1, 2, 3, 4, 5, and B equal to the set 4, 5, 6, 7, 8. A or B. So as usual, A or B means you are putting the two together. So if you put the two together, you are going to get 1, 2, 3, 4, 5, 6, 7, 8. Notice that your 4 and 5 are not listed twice. There is 4 in set A, 4 in set B, and we record that only once. We do not repeat it. 5 is also in set A, 5 is also in set B. So we record that once. That is all. The second one, A intersection B, which is the same as A and B, means the events A and B occur together. So if you have the event A and B occurring together, this is called a joint event. That is, they are coming together. They have something in common. A intersection B, the two events have something in common. For example, let A and B be 1, 2, 3, 4, 5, and then 4, 5, 6, 7, 8, respectively, which means that the first set there, which is the 1, 2, 3, 4, 5 is set A, 4, 5, 6, 7, 8 is set B. So if you have A and B, A and B means A intersection B. Which members are in the first set and at the same time in the second set? Dance piece. I'm a macho carriage.
Sir,
Yes. Are you following what we are doing?
yes, please.
What did I say?
You said if you are finding the intersection of A and B,
Mhm.
we are taking the numbers that are in A and that can be found in B as well,
Okay.
which is 4 and 5.
Okay. All right. So the two sets we have there, you can see 4 in the first set, 5 in the first set. Then if you go to the second set, 4 and then 5 are also present in that set. So A and B will give us what? 4, 5. Okay. Please, have you finished copying?
Yes, sir.
Okay. Mutually exclusive event. This is another type of event. Mutually exclusive event. If please, you must know these definitions by default. If the occurrence of one event excludes the occurrence of another event, such events are mutually exclusive events. That is, two events don't have any common point. So when two events have nothing in common, two events, they have nothing in common, meaning they don't have any intersection, we say the two events are mutually exclusive. For example, if X and Y are events such that the two events cannot occur together or at the same time, then we say that the events X and Y are mutually exclusive events. That's all. They cannot occur together. Let's consider this one. So therefore, X intersection Y will be equal to empty set, which means that the set X and the set Y do not have any member in common. Let's look at the second one. If S equal to this, and E1, E2 are two events such that E1 consists of numbers less than 3. Please, which are the numbers less than 3 there in that set?
Please come again.
Are you following?
Yes.
You know, people,
Yes, sir.
you have to pay much attention. Leave whatever is going on around you and focus here, else you will not follow what we are doing. You know, this is a technology. And if you are not able to pay attention, you wouldn't understand. Okay? So stop whatever you are doing and pay attention to what we are doing here. Please. If S equal to 1, 2, 3, 4, 5, 6, and E1, E2 are two events such that E1 consists of numbers less than 3, and I'm saying that which are the numbers less than 3 in the set S?
1 and 2.
1 and 2. Excellent. And
Yes, sir.
E2 consists of numbers greater than 4. Which are the numbers greater than 4 in that set? Akitipel.
5 and 6.
5 and
5
6.
and 6.
Excellent. Now, so
5
we
and
have
6.
E1 equal to 1 and 2, and E2 5 and 6. Then E1 and E2 are mutually exclusive. If you check the two events, E1 1 2, E2 5 6, you see that they have nothing in common. So we say that the two events are mutually exclusive. The two events are mutually exclusive. All right. Any question here? Emmanuel, Jessica, any question?
No, sir.
Jack Pasu, Philippine, any question?
No.
MFA Kusogbo, any question?
No, sir.
So MFA, if no question, what will be the intersection of E1 and E2? Intersection of E1 and E2. Yes, if you know it, you can raise your hand. Donko Ajwa Bright. Intersection of E1 and E2.
Sir, 1, 2, 5, and 6.
Asiedu Divine. Intersection of E1 and E2. Mavis Mensah, intersection of E1 and E2.
Say empty set.
Empty sets. They have nothing in common. So the intersection of E1 and E2 is empty. They have nothing in common. So if they don't have anything in common, they are mutually exclusive events. Danso Peace, do you understand that?
Yes, sir.
Domenia Raymond, do you understand that? Okay, let's move on. Independent events and dependent events. Let's just take them quickly. If the occurrence of any event is completely unaffected by the occurrence of any other event, such events are known as independent events in probability. And the events which are affected by other events are known as dependent events. So if you have two events, let's say A and B, and the presence of A, if the presence of A does not affect the presence of B, we say that they are independent. Like each of you, when you are coming to school, you coming to school will not have any effect on anyone who is also in school. So you are all independent. Do you understand that? But if you depend on something for you to progress, like you in per se, as individual student, you are dependent because you are depending on your parent. Without your parent, you cannot come to school. So you are dependent event. But you coming to school has nothing to do with another person also coming to school. Are you okay? Peace. Peace, are you okay?
Yes, sir.
Please, if I ask a question, if I call you, you should respond so that I will know you are with me. Is that right? Kumi Monica, do you understand that?
Yes, sir.
Good. Miriam, I hope you are getting it. Let's go to the next thing then. For example, two events X and Y are said to be independent if the occurrence of X does not affect the occurrence of Y and vice versa. So either both sides. Yeah. Good. Next slide. Exhaustive. This is exhaustive events. So a set of events is called exhaustive if all the events together consume the entire sample space. That's all. Exhaustive events. And I think that will be the last type of event we will consider in this lesson. Sorry. Sample space. Very interesting. Very important too. Sample space is for simple experiments. I want to see how we can write sample space for a given simple statement or simple experiment. Let's see. 1. So we take 1. We want to write a sample space. If a fair coin is tossed once, then the sample space is given by S equal to this. You see, I use the curly bracket, not the ordinary bracket. So I'm using this curly bracket to denote my set. So please take note of that. It is not the ordinary bracket. Now, so if the sample space is given by S equal to now, like we said earlier, the H there is the event that H will show. The T here tells you the tail, that is the other side. If the first side is the head, the second side will give us the tail. And the number of events there gives us 2, which means that the set of possible outcomes will be 2 if you toss a coin only once. Either you get the head first or the tail. So if you put them together, you get 2 events. That's the first thing. Again, so like I said, note H equal to the head and T equal to the tail. We have the second one. When an unbiased die is tossed once, then the sample space is S equal to, you see, a die like I showed earlier on. It has 6 faces. So if you roll your die, either 1 will show, or 2 will show, or 3 will show, or 4 will show, 5 or 6. And if you count all the numbers that are possible, that are likely to show, you will get 6. So we say that the sample space, the number of events here is 6. Take note of that. The number of events here is 6. Good. So sample space for compound experiment. So if you have compound experiment, Danso Peace, did you copy the first one?
Sir, please, I'm done. I'm done copying it.
Mavis Mensah, did you also copy that?
Yes, sir.
Okay. Owusu Godwin, did you do that? William Shepherd, did you do that? Were you able to copy it? I didn't hear you. Okay. Compound. So like we said, compound experiment, combination of two or more simple experiment will give you a compound experiment. So we are going to pick some examples and see how compound experiment occur. The first example, when two fair coins are tossed once, then the sample space is, so you have two fair coins. And we know that if you toss a fair coin once, your sample space is going to be 2, right? Isn't it? Miriam, isn't it? Amadi Prosperity, isn't it? Apedo Root, isn't it?
Yes, sir.
Okay. So now we are going to toss two fair coins. Now, if you toss two fair coins once, is the same as you tossing one coin twice. If you toss two fair coins once, is the same as tossing one coin 2 times. So if 2 coins are tossed once, the sample space will be this. Hold on, let me see what is happening here. Let me show you the sample space when you have uh, 2 fair coins tossed once. The sample space. Let me go there. Okay, so the first coin will give us the head and the tail. You see, that's coin A. Will give you this head and then this tail. If you toss coin A once. Now, if you toss coin B, it will also give you the head and the tail here. But if you toss 2 coins, you know that you need 2 results. The first coin will give you a result. The second coin will also give you a result. So we put that together. Now, if you put it together, both coin A and coin B will now give us head-head. That is this and this will now give us head-head. That is H and H will give us HH. Are you okay? Peace.
Yes, sir.
Raymond, are you okay?
Yes, sir.
Good. Akitipel, your hand is up.
Sir, please, can you go back?
Come again, please.
Sir, please, can you go back?
Can I?
Sir, please, can you go back?
Okay.
Go
We have
back.
two coins. The 2 coins roll 2 fair coins tossed once. So if you toss the 2 coins once, it's the same as tossing 1 coin 2 times. Okay. So the set of possible outcomes for coin A will now give us this. Coin A, the set of possible outcomes is going to be head, tail. That would be the set of possible outcomes. Head, tail. Let me circle that. Let me circle that. Head and then tail. Can you see that, Akiti?
Yes, sir.
Now, if I toss coin B, it is also giving me this result. Can you see that one too?
Yes, sir.
Good. So, and you know that if you toss 2 coins, you will get result from the first one and the result from the second one. Okay? You are going to put that result together. So you will get 2 results. So this and this will now give me head, head. Can you see that? Meaning the first result and the first result from B, the first result from A, first result from B will give me head, head. Akiti, did you get that? Akiti
Yes,
is
sir.
not okay. Now, again, you will also get this. That's the first result from A and the second result from B will also give you head, tail. Can you see that? Meaning the first coin A will give you what? Head.
Yes,
And
sir.
the second coin B will give you tail. Did you see that? Again, if
Yes, sir.
you take the first coin, if you pick these 2 results, the second result there and the first result in coin B, it will also give you tail, head. Okay?
Yes, sir.
If you do the same thing to this, you combine this and this, it will also give you tail, tail. Is that clear? So the set of
Yes, sir.
possible outcomes will be head, 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 tail, head, tail, tail. Let's all take it wherever you are. 1, go. Head, head, head,
Head,
tail,
Head, head,
tail,
head,
tail,
Head,
tail, tail,
tail,
head,
tail.
head.
All right.
head, tail, head.
All right. So now, if you count all the results over there, you see 1, let me underline that so that you see. If you count the result, we are going to get 4. Your sample space or the number of events is going to be 4. Now we have head, head. This is 1. Are you okay? Head, tail. This is 2. Tail, head. This is 3. Tail, tail. So we have 4. So the number of events here is 4. And that is the universal set. That is the sample space. Is that clear? Is that clear?
Yes, sir.
All right. So when they ask you
Yes,
to write the sample
yes,
space,
sir.
when 2 fair coins are tossed once, you are going to get head, 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 tail, tail, head, tail, tail. You must know this by default. Again, let's go to the next one. The next one there is when 3 fair coins are tossed. So we've moved from 2 to 3. When 2 fair coins are tossed, that is, they are tossed once. The sample space is this. Now, 3 fair coins. It is difficult to get the result if you throw all the 3 together. It becomes so complicated. So what we do is that we throw 2 coins and then we toss another 1 coin. So if you roll 2 coins, please mute yourselves. If you roll 2 coins, we know that the result is going to be 2 coins will give us the result head, 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 tail, tail, head, tail, tail. That is the result when you toss 2 coins. And the third one, we throw the third one separately. So if you do that, that will also give you head and then tail. Head and tail. Now, we put them together, the result from the 2 coins and the result of the single coin. Now, if you pick them one by one, if you combine the result, the first result, it will give you head, head, head. Danso piece, do you get that?
Yes, sir.
Again, if you toss this one, this will also give you, you see, you pick the 2, head, head, tail, head, head, tail. Now, again, if you take this, head, tail, head. So we have head, tail, head here. Now, if you combine this to this one, this will also give you head, tail, tail. You see, we have one T here, another T here. So head, tail, tail. And then you do the same thing to this one, and this will also give you tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So the sample space in this case will be 8. The sample space will be all the events giving us 3 results. So you count all the events with 3 results there, and that will give you 6. So the result we count over here is this one. That is the one in the blue ink. That is the result we consider. So if you count all this, the whole of this 1, 2, 3, 4, 5, 6, 7, 8, and that gives you a sample space of 8. Any problem to this? Raymond, do you have any problem?
No, sir.
Okay. Amanyo Jessica, any problem?
No, sir.
Atrim Chaslina, any problem?
No, sir.
Deborah Paula, are you okay?
Yes, sir.
Chantal, are you okay? Are you getting everything?
Yes, sir.
All right, copy that quickly. Then we move to the next slide before we end this section this morning. It's almost time. Please make sure you copy it the way you see it there. Just copy it the way you see it there. Boglovo Adam, have you finished?
Yes, sir.
Okay. Jakpasu Philippine, have you finished?
Yes, sir.
Sando Francisca.
Yes, sir.
Okay. Let's take probably the last one. The last for today. That I wish we do the last two. The next one is this. When 2 unbiased dice are thrown, so we are going to we are done tossing coins. Now we are moving to dice. So when you have 2 unbiased means that they are fair. Unbiased means that they all have the same side and shape. So if you have a die, 2, dice is the same as tossing one die 2 times. If you toss 2 dice once, is the same as tossing one die 2 times. Let's look at the result here. So the first die we know will give us the result 1 up to 6. Let me use the red ink. The first gives the result from 1 up to 6 because a die has 6 faces. The second die or the other die will also give the result from 1 up to 6. So we are going to combine the result from both dies. And if you combine the result from both dies, this and this will give us what? 1, 1. This and this will also give us 1, 2. This and this will give us 1, 3 in that order. Now we also have 2 and 1 will give us 2, 1. This 2 and this 2 will give us 2, 2. This and this will give us 3, 3, which means that the first die will turn, die A will show 2 or it will turn 2. And then die B will turn 3. 2, 4 means that die A will turn 2. And if you go to die B, it will turn 4. That is what it means. So you will do it till you finish. So you will see that this is a square. The number of rows is equal to the number of columns. So if you want to find the sample space, you are going to count the possible outcomes. You consider the possible outcomes with 2 results. So our sample space, we are going to count all the results in this box. This is a square. So if you count them, this will give us 1, 2, 3, 4, 5, and 6. Then the number, that is the number of columns. And the number of rows, we know as usual, this is 1, 2, 3, 4, 5, 6. So you will see that the number of rows is equal to 6. The number of columns is also equal to 6. So your sample space here is going to be all the elements that I've selected, and that is going to be 36. Your sample space here will be 36. That is 6 times 6 will give you 36. Is that clear? Peace, is that clear?
Yes, sir.
Raymond, is that clear?
Yes, sir.
All right. So let me see. We go to the very last one. When a fair coin and an unbiased die are thrown, the sample space is this. When you have a fair die and a fair coin and unbiased die. So if you toss your die, we know it will give you the result. It will give you the result 1 to 6. That is if you toss your die. And if you toss your coin, it will also give you the result head and then tail. That is for the coin, head and tail. Now, if you put them together, this will give you H1, which means that the coin will show head and then the die will also show 1. This will give you H2, which means the coin will show head and then the die will show 2. This will give you H3. The coin will show head and the die will also show 3 in that order. Then when you come to the next one, that's picking the tail one after the other in combination, T and then 1 will give you T1, which means that the coin will show tail and the die will also turn 1. So you do it this way. So in this case, the set of possible outcomes, is going to be all of this. Who can give me the sample space over there? Peace, give me the sample space.
H1, H2, H3, H4, H5, H6, and the T1, T2, T3, T4, T5, T6.
Good. So what will be the number of events? The number of events, Raymond.
36.
The number of events, Raymond.
Set 12.
12. How did you get the 12?
So I counted the number of events.
You counted?
The number of events.
Okay. So you see all that I've circled in the red box there will give you the number of events. So we have 12. That is your sample space. So ladies and gentlemen, this is how far we've come today. Uh, we know the various types of events, and we can write the sample space for some experiment. I want to encourage you to go out there and then do a lot of practice on this, so that when we start using them, you will not find yourself wanting. Is there any problem?